Hello everyone, welcome to the module on the introduction to computer memory. In this module, we are going to talk about basics of computer memory. Before that, let us recollect the components of a computer. Now you can watch the video on the basic components of a computer. Well, having seen the basic organization of a computer and its working, let us now get into the details of one of the important components of a computer, that is nothing but memory. In the earlier modules, you would have heard the term memory. We have also used the terms such as data and instructions. But what do they really mean? What exactly is memory? How does the computer use them? This is what we are going to discuss in this module. When we carry out calculations with pen and paper, we have to save the temporary or intermediate results, and we do so by using a piece of paper. Here the paper is used as memory for storing the results. So, memory takes up some space. Now coming to the computers, they do contain memory. We can think of memory as a piece of paper for the computer. So, computers do contain memory. A computer is a device operating under the control of instructions stored in its own memory and that can accept input, process the data according to the instructions, produce output and store the information for future use. Now, let us see the role of memory in human life. Then we will relate the human memory with computer memory. Memory plays a significant role in our daily life. It allows us to remember skills what we have learnt, retrieve information whenever needed or recall a precious moment in our life. Memory organizes information and we can apply that information in the proper context when we retrieve it. We use short term memory to recall information when we have learnt recently. Long term memory is used to recall the information anytime in the recent past to the childhood. Coming to the computer memory, a computer memory is just like a human brain. It is used to store data and instructions. It is the storage space in the computer where the data is to be processed and instructions required for processing are stored. CPU of a computer manipulates data by performing computations. In real world, all the computers use a storage hierarchy, which puts fast but expensive and small storage options close to the CPU and slower but larger and cheaper options further away. Generally, the fast volatile technologies are referred to as memory. What does a volatile mean? Here volatile means when the power is switched off, the memory loses its contents. Then the slower persistent technologies are referred to as storage. Now let us look at how a computer memory is organized. In many ways, human memories make us who we are, helping us remember our past, learn and retain skills. And for the computers that often acts as extension of ourselves, memory plays a similar role. Whether it is a movie or a text file or the instructions for opening any one of them, everything in a computer's memory takes the form of basic units called bits or binary digits. Each of this is stored in a memory cell that can store one of the two states, namely on for 1 or off for 0. Let me tell an analogy for better understanding of the states of the bits. You may consider that electrical switch is 1 bit and it can store 2 states. Switching it on may be considered as 1 and off may be 0. Similarly, a bit can store either 0 or 1. The files and programs are made up of millions of bits which are processed by CPU. You all know that group of 8 bit is a byte. Group of bytes make a word. Word size refers to the number of bits processed by a computer's CPU in one go. These days typically 32 bits or 64 bits. A simple way of looking memory is shown on the screen. Each word has an address to uniquely identify it. In the example shown, it is 1000. How does a computer memory look like? Now you can see a typical RAM on the screen. This memory module can be integrated into computer motherboard. Do you know what is a motherboard? Let me recall what it is. The motherboard is a printed circuit board located on the back side or at the bottom of the computer chassis. It allocates power and allows communication between the hardware components of the computer. For our understanding, we can visualize memory as shown just now. Having seen the introduction and organization of memory, we move on to the classification of computer memory. Memory is the storage part in a computer. It stores data either temporarily or on permanent basis. The memory is basically classified into two types, namely primary and secondary memory, as can be seen here. So, shall we learn about primary memory? Every computer comes with a certain amount of physical memory, usually referred to as main memory or RAM. You can think of a main memory as an array of boxes, each of which can hold a single word, which is group of bytes of information. Primary memory is internal memory of the computer. It is also known as main memory or temporary memory. Main memory holds the data and instruction on which the computer is working presently. Primary memory is volatile in nature. If your CPU accidentally gets unplugged or switched off, any data saved in the memory is lost. Volatile memory is a computer memory that requires power to maintain the stored information. Primary memory is generally of two types, RAM and ROM. RAM, it stands for random access memory. RAM is also known as read-write memory. It generally referred as main memory of the computer system. It is a temporary memory. The information stored in this memory is lost as the power supply to the computer is switched off. That is why RAM is also called volatile memory. Whenever you execute a program, you actually load its instruction and the required data into the RAM memory. However, RAM memory is lost whenever we shut down the computer. That is why we cannot keep everything in RAM and expect the computer to be faster overall. Random access memory is further classified into two types, namely static and dynamic RAM. Now, let us see about static RAM. Static RAM, also known as SRAM, retains stored information as long as the power supply is on. SRAM are of higher cost and consume more power. They have higher speed than dynamic RAM. Each cell in the SRAM is made up of 6 transistors, which can store 1 bit of information. Let us not delve into the working of a SRAM cell. You refer some online materials to understand it. Dynamic RAM. It is also known as DRAM. DRAM stores bits in cells consisting of a capacitor and a transistor. The capacitor can be either charged or discharged. These two states are taken to represent the two values of a bit, namely 0 and 1. As the capacitors tend to lose the charge stored on them even though the power supply is on, they need to be refreshed at regular intervals to maintain the information. Now, let us compare the features of SRAM and DRAM. Static RAM uses transistors to store a single bit of information, whereas DRAM uses capacitors to store each bit of information. SRAM does not require refreshing to maintain the information, whereas DRAM needs to be periodically refreshed to retain the stored information. So, this is so because the capacitors tend to lose their charges. SRAM has structure that is more complex than DRAM, but SRAM is faster than DRAM. So, they are used in cache memory, which we will discuss shortly. DRAMs are mainly used in main memory, that is primary memory. Next, we will look into ROM, that is read only memory. ROM, it is an acronym for read only memory. ROM is a permanent memory. Unlike RAM, ROM is non-volatile. Any data written to this memory will stay there until it is overwritten. That is, the content is not lost even after you turn off your computer. The contents of ROM is burnt by the computer manufacturer and permanently stored at the time of manufacturing. So, ROM cannot be overwritten. So, it is also called as non-volatile memory. A typical ROM is shown on the screen. Now, we see what is ROM memory used for. Every computer comes with a small amount of ROM containing the boot firmware. On a PC, the boot firmware is also called BIOS, that is Basic Input Output System. ROM consists of a few kilobytes of code that tell the computer what to do when it starts up. That example, running hardware diagnostics and loading the operating system into RAM. At the end of this module, let us enumerate the activities involved while switching on the system. Originally, ROM was actually read only. To update the contents of ROM, earlier you had to remove and physically replace your ROM chips. Contemporary versions of ROM allow some limited rewriting, so you can usually upgrade firmware such as the BIOS by using installation software. This leads to variants of ROM. Let us present a brief overview of them. The first variant is PROM. PROM is an acronym for Programmable Read Only Memory. This is a memory chip on which information can be written only once. Once some information has been written onto a PROM, it remains there forever like ROM. Unlike RAM, PROMs retain their contents when the computer is turned off. Then, in what way does PROM differ from ROM? The difference between PROM and a ROM is that PROM is manufactured as blank memory, whereas ROM is programmed during the manufacturing process. Once the PROM has been programmed, the information written is permanent and cannot be erased or deleted. To write the data onto a PROM chip, you need a special device called PROM programmer or PROM burner. The process of programming a PROM is sometimes called burning the PROM. EEPROM. If a PROM has been programmed and has an error and needs to be updated, then the chip has to be discarded and a new PROM is created and replace the old chip. It is an EEPROM, that is electrically programmable read only memory, which is a PROM that can be erased and reprogrammed without being replaced. EEPROM is a special type of memory that retains its contents until it is exposed to ultraviolet light. The ultraviolet light clears its content, making it possible to rewrite the memory. Like PROM, you need a special device called a PROM programmer or PROM burner to write to and erase an EEPROM. EEPROM, short form of electrically erasable programmable read only memory. A major drawback of EEPROM is that the chip must be removed from the circuit for programming and that its entire contents are erased by ultraviolet rays. EEPROM is a special type of PROM that can be both programmed and erased by exposing it to special electrical waves in millisecond. These chips need not be removed from the circuit for programming and allow the cell contents to be erased selectively. Like other types of PROM, EEPROM retains its contents even when the power is turned off. Also, like other types of ROM, EEPROM is not as fast as RAM, and EEPROM requires different levels of voltage for erasing, writing and reading. Flash EEPROM. The next type of ROM is flash memory. Flash EEPROM has become a popular user programmable memory chip. The important features of flash memory include: first, flash memory takes less than a second to the erasure of entire contents, or we can say in a flash, hence it is a name flash memory. In addition, the erasure method is electrical, and for this reason it is sometimes referred to as flash EEPROM. The major difference between EEPROM and flash memory is that when the flash memory's contents are erased, the entire device is erased, in contrast to EEPROM where one can erase a desired byte. In a flash memory, it is possible to read the contents of a single cell. So, let us wind up the primary memory by saying a few points on a RAM and ROM. ROM is a permanent memory which stores all the data which is required to run the computer. The data stored in it does not get affected unless the user decides to modify the files, hence it is non-volatile. RAM, it is a temporary memory storage device which gets cleared after the user shuts down the computer. RAM is used as a rough paper on which applications do all their calculations. Once the calculations are done, RAM gets cleared, hence RAM is volatile. Both RAM and ROM are required to run a computer because they are interdependent on each other. As ROM stores both files and applications, RAM is required for working on those applications. If there is no RAM and ROM, computer will not boot up. You cannot use a computer without any one of them. So far, we have been discussing about primary memory. There is another type of memory called secondary memory. We will examine it now. Let us see why do we need secondary storage device. Any guesses? Suppose we want to store files over a long period of time. We store photos, videos, audios, documents and spreadsheets on our computers. We also expect our programs to be there when we switch the computer on or off. This long term storage is called secondary storage. Although RAM can store the data and programs used when a computer system is actually running, it is volatile, meaning it loses its contents without a power source. Secondary storage is therefore needed because it is non-volatile, meaning it would retain its content without the need for a power supply. It also has the large storage capacity needed to store the operating system and all the programs and files needed by a modern computer system. Because we need a lot of it, it therefore needs to be cheap. Can you say a few examples for secondary storage devices? Magnetic storage devices like floppy disk, hard disk, optical storage devices like CD, DVD, solid storage devices are examples for secondary storage devices. We have learnt earlier that ROM is non-volatile. Then what makes the difference between ROM and secondary storage device? ROM is a chip with the data on it, that is device containing a program. Data or information about the devices has been programmed during the manufacturing, and it is not easy to rewrite or modify any data on ROM. You can get variant types of ROM, but in the essence they are designed to be written to once. This is a memory that has been burnt with the code required to kickstart the CPU. For example, the code that operates washing machine, microwave oven, etc. is burnt onto the RAM only, so that the appliance is ready to use when turned on, whereas the secondary storage devices are external storage mediums used to store the data by users. Any data on a secondary storage device can be deleted, modified, rewritten easily. It is very common for a new computer users to be confused by what parts in the computer are memory. Although both the hard drive and RAM are memory, it is more appropriate to refer to RAM as memory or primary memory and hard drive as storage or secondary storage. Now, let us briefly present the features of secondary devices. There are certain distinguishing features of secondary storage devices that make unique. Can you imagine what it could be? Suppose a company wants to store the sales details of 1 year. What could be the size of the details? Maybe in gigabytes or in terabytes, a huge size. Such a large capacity of data can be stored in secondary storage devices. That is, the capacity is one of the distinguishing feature. Which is the amount of data to be stored or the size of the file? Then comes speed. This is how quickly the user can access the data from the storage device. The third feature is portability. Whether the data needs to be moved from one place to another, such as from office to home. Some companies store backups of important data off-site. Remember that a lot of secondary storage device needs to be portable. The next feature is durability. It means how long the storage media can be reasonably expected to last. Finally, we have reliability. This refers to whether the data can always be accessed reliably and in the format in which it was saved. Well, shall we compare primary and secondary memories? First, let us have a look on the features of primary memory. Primary memory is also known as main memory or internal memory. In primary memory, data is directly accessed by the processing unit. Semiconductor chips are used to store information in the primary memory. Information stored is temporary and it can be lost when there is a sudden power cut. Primary memory devices are more expensive than secondary storage devices. Primary memory varies like RAM, which is volatile in nature, ROM, which is non-volatile. It is very fast in interacting with microprocessor. Primary memory has limited storage capacity. Examples: RAM, ROM, cache memory, PROM, EEPROM, registers, etc. Now, we will look into the features of secondary memory. Secondary memory is also known as external memory or auxiliary memory. In secondary memory, data is first transferred to the main memory and then routed to the processing unit. Magnetic disk, optical disks are used to store information in secondary memory. Information stored is permanent unless one deletes it intentionally. Secondary memory devices are less expensive when compared to primary memory devices. It is always non-volatile in nature. It is little slow in interacting with microprocessor. Secondary memory can store bulk amount of data in a single unit. Examples: magnetic tapes, optical disk, floppy disk, flash memory, that is USB drives, paper tape, punched card, etc. Having seen in detail about the memory, let me pose some questions. See whether you can answer those questions. What happens to memory when the computer is turned off? Because RAM is a volatile memory, when the computer loses the power, anything stored in RAM is lost. For example, as you are working on creating a document, it is stored in RAM. If it is not saved to non-volatile memory, it would be lost if the computer lost power. How is memory used? When an application program such as MS Word is opened, it is loaded into RAM, which allows the program to communicate with the processor at higher speeds. Anything you save to your computer such as picture or video is sent to hard drive for storage. Why is memory important or needed for a computer? Each device in a computer operates at different speeds, and computer memory gives your computer a place to quickly access data. If the CPU had to wait for a secondary storage device like a hard disk, a computer would be much slower. Now, let us see how the memory is involved in the process of booting. All of the components in your computer such as CPU, the hard drive and the operating system work together as a team. Memory is one of the most essential part of this team. From the moment you turn your computer on until the time you shut it down, your CPU is constantly using the memory. Let us take a look at a typical scenario. Turn on your computer. When the power gets on, memory testing, that is RAM test, is performed. The computer loads the data from read-only memory and performs power on self-test to make sure all the major components are properly functioning. As a part of this test, memory controller checks all of the memory addresses with a quick read and write operation to ensure that there are no errors in the memory chip. Read write means that the data is written to a bit and then read from that bit. The computer loads the basic input output system, which is abbreviated as BIOS, from ROM. The BIOS provides the most basic information about storage devices, boot sequence, security, plug and play, which is auto device recognition, and few other items. The computer loads operating system from the hard drive into system's RAM. Generally, the critical parts of the operating system are maintained in RAM as long as the computer is turned on. This allows the CPU to have immediate access to the operating system, which enhances the performance and functionalities of the overall system. After successfully loading the operating system, you can see the prompts. If the operating system is DOS, then the prompt may be A, B or C. If it is Windows, then a desktop is displayed with a start button. When you open an application, it is loaded into RAM. To conserve RAM usage, many applications load only the essential parts of the RAM initially and loads other pieces as needed. After an application is loaded, any files that are open for use in that applications are loaded into RAM. When you save a file and close the application, the file is returned to the specified storage device and the application is purged from RAM. So, in the list above, every time something is loaded or open, it is placed into RAM. This simply means that it has been put in the computer's temporary storage area, so that the CPU can access that information more easily. The CPU requests the data it needs from RAM, processes it and writes the new data back to RAM in a continuous cycle. In most computers, this shuffling of data between the CPU and RAM happens millions of times every second. So, when an application is closed, any accompanying files are usually purged from RAM to make room for new data. If the changed files are not saved to a permanent storage device before being purged, they are lost. Now, I hope you would have received sufficient details about computer memory. Now, we will move on to another small topic called registers. What are registers? Why do we need them? Registers are used to quickly accept, store and transfer data and instructions that are being used immediately by the CPU. There are various types like accumulator, memory data register, memory address register, program counter, etc. You may be wondering, why do we need to use registers in addition to using memory? Why not just use memory? The reason is that doing calculation in a register is much faster than doing calculation in memory. Registers are placed inside the CPU right to the ALU, so the signals can travel almost right away. They are also the fastest memory type, but they take significant space, so we have only a limited number of them. Registers vary in both number and size depending on the CPU architecture. Some processors have 8 registers while others have 16, 32 and so on. For many years registers were 32-bit, but now many are 64-bit in size. A 64-bit register is necessary for a 64-bit processor since it enables the CPU to access 64-bit memory addresses. A 64-bit register can also store 64-bit instructions which cannot be loaded into a 32-bit register. Therefore, most programs written for 32-bit processor can run on 64-bit computers, while 64-bit programs are not backward compatible with 32-bit machines. We have seen enough about memory. Now, we are going to explore the memory hierarchy. To this point in this module, we have assumed that the memory system is a linear array of words and the CPU can access each memory locations. While this is an effective model as far as it goes, it does not reflect the way the modern systems really work. In real, a memory system is an hierarchy of storage devices with different capabilities, cost and access times. CPU registers hold the most frequently used data. Small, fast cache memories nearby the CPU act as storage areas for a subset of the data and instructions stored in the relatively slow memory. The main memory in turn serves as a storage areas for the data stored on the disk and tapes. See the figure for memory hierarchy in a typical computer. Even though we have not discussed about cache memory earlier, let me give a brief note of it. Cache memory is used to enhance the performance of the PC. It holds the data and instructions retrieved from the RAM to provide faster access to the CPU. It is placed between the CPU and the main memory. As a computer system is manufactured using components from different vendors, there are no standards on speeds and transfer rates of these components. The CPU and main memory overcome these differences by using cache memory. Cache memory is an extremely fast memory type that acts as a buffer between RAM and CPU. It contains frequently used data and instructions so that they are immediately available to the CPU whenever needed. Cache memory is generally present in two places, namely inside the processor, which is called as internal cache, and on the motherboard, which is called as external cache. What is internal cache? It is also known as primary cache and located inside the CPU. Next, what is external cache? It is also known as secondary cache and it is located on the motherboard outside the CPU. Memory hierarchies work because well written programs tend to access the storage at any particular level more frequently than they access the storage at the next lower level. So, the storage at the next level can be slower and thus larger and cheaper per bit. The overall effect is a large pool of memory that costs as much as the cheap storage near the bottom of the hierarchy, but that serves data to the programs at the rate of fast storage near the top of the hierarchy. As a programmer, you need to understand the memory hierarchy because it has a big impact on the performance of your applications. If the data your computer needs are stored in a CPU register, then they can be accessed in 0 cycles during the execution of the instruction. If stored in a cache, 1 to 30 cycles. If stored in main memory, 50 to 200 cycles, and if stored in disk, tens of millions of cycles. So, if you understand how the system moves data up and down the memory hierarchy, then you can write your application program so that their data items are stored higher in the hierarchy when the CPU can access them more quickly. So, we come to the end of the module. Let me briefly summarize what we have learnt in this module. In this module, we had a quick introduction to the memory of a computer, its types, namely primary and secondary memory, and their features. Also, we have discussed about the types of primary and secondary memory. Next time when you use the data, you will definitely understand the whole process. At the beginning of the module, we have also shown the components of a computer. So, next time when you see the configuration of a computer, you will understand the purpose of each component in it. And what would you want to learn more about? Leave me a comment in the discussion forum.